rolling. This is Extra Credit for Physics, Session 1, Beginner Kinematics and Force Problems by Carly Cohen. The use of the back page of the reference table will be necessary to complete these problems. First problem. How far will a brick fall freely starting from rest in 3 seconds? So in this problem we're given time, which is 3 seconds, and we are to imply that the acceleration is 9.81 meters per second squared, which is the acceleration due to gravity on Earth. Also, we imply that the initial velocity is 0, because it says it's starting from rest. To complete this, and we are looking for d, which is distance. Distance is our x. Now on the back sheet of the reference table, the formula you would use is distance equals initial velocity times time plus 1/2 acceleration times time squared. So distance is our x, so it's that. So the initial velocity is 0, the time is 3 seconds, plus 1/2 of our acceleration, 9.81, times our time, 3 seconds squared. So d equals 3 times 0 is 0, so that negates that. 1/2 of 9.81 is 4.905 times 3 squared, which is 9. So the distance it will fall is 44.154 meters. So in significant figures, the distance is 44 meters. And that's how you answer this question. Now the key concepts in answering this question are to figure out the implied values and substitute known values into the formula. Next question. A spring scale reads 20 newtons as it pulls a 5 kilogram mass across the table. What is the magnitude of the force exerted by the mass on the spring scale? So the force is 20 newtons and the mass is 5 kilograms. So in this problem, it would be necessary, in this problem, what they're asking is the force exerted on the scale by the block. And according to Newton's law, every action has an equal and opposite reaction, which would make the force exerted on the scale the same as the force exerted on the block. So the answer is 20 newtons. Next question. No, the key concept behind this is to remember that every action has an equal and opposite reaction. The next question. A net force of 10 newtons accelerates an object at 5 meters per second. What net force would be required to accelerate the same object at 1 meter per second? So the force is 10 newtons and the acceleration is 5 meters per second squared. And they want to find what the acceleration would be when the acceleration is 1 meters per second squared, what the force would be. So the force is x. And in this problem, you would set up a proportion. So 10 over 5 is equal to x over 1. You would then cross multiply. X times 5 equals 1 times 10 5x equals 10, divide by 5, x equals 2. So the force needed to accelerate the object 1 meter per second is 2 newtons. The key concept behind this question is to know how to set up a proportion and then cross multiply. Next question. A car travels 90 meters due north in 15 seconds. Then the car turns around and travels 40 meters due south in 5 seconds. What is the magnitude of the average velocity of the car during this 20-second interval? So the car, so north, south, east, west. So the car travels due north 90 meters, and it then turns around and travels due south 40 meters. And they want to know the average velocity. So that is the displacement. They would want the average velocity from the displacement of the origin. So you would add the vectors. So 90 minus 40 equals 50 meters. And then the total time is 20 seconds. And you would substitute in the formula distance equals velocity times time. If your distance is 50 meters, then your velocity is your x, and your time is 20 seconds. Then you divide 50 by 20, and you get your v, or velocity, to be 2.5 meters per second. So the average velocity of the car during the 20-second interval is 2.5 meters per second. Now, the key concept behind this problem is to know what magnitude and displacement mean. Displacement is the distance from the origin. So that's why we subtracted the 90 from the 40 to get to 50, which was the displacement from the origin. You also need to know that they're only looking for magnitude and not direction. So you would negate the north and the south. Thank you, and that was session 1 of Extra Credit for Physics. Carly out.